Very good morning, students. After the completion of process of electrolysis in aqueous state, now we take Faraday's law of electrolysis. There are two laws of Faraday. Faraday's first law, write down. Faraday's first law of electrolysis. According to this law, the mass of substance or electrolyte is directly proportional to the quantity of charge supplied by electrolytic solutions. The mass of substance is directly proportional to the quantity of charge supplied by the electrolytes in the electrolytic solutions. Let W is the amount of substance, so Q is the quantity of charge in coulomb. So according to this law, W is directly proportional to the Q, or W is equal to Z into Q. It is the equation 1. What is Z here? Well, Z is the electrochemical equivalent, and Q is equal to current in ampere and time in second. Q is represented as current in ampere, conventional current I, and time T. So W is equal to Z into I into T, and I is the applied current, time in time in second. So if it is given in minutes, multiply by 60. If it is given in hours, then multiply by 60 into 60. Right now, so where Z is electrochemical equivalent, Z is defined as when the current is supplied in 1 ampere and time in 1 second is called electrochemical equivalent. So if we have to calculate the mass of the electrolytic solutions, then W is equal to Z into I into T. Or if that the Z is the electrochemical equivalent when current is applied in 1 ampere and time is in 1 second, so W is equal to Z into, you can see 1 into 1. So W is equal to, what is that? W is equal to Z. So it is equal to the electrochemical equivalent. Now, before that, present you the numerical based on Faraday's first law of electrolysis. If you have to calculate, you can see one thing you have to remember: Faraday's constant. How can you get the Faraday's constant? This is the charge of electron to be multiplied by, what is that? Avogadro number. 1.602 into 10 to the power minus 19 coulomb to be multiplied by 6.022 into 10 to the power 23. Approximately you have to take in coulomb, that is equal to 1 Faraday. How much charge? Solve the question from the textbook. How much charge is required to reduce 1 mole of aluminum ion to, what is that? Aluminum. 1 mole of copper ion to copper, and 1 mole of MnO4 1 negative to Mn2 positive, and the fourth 1 mole of Cr2O7 2 negative to chromium 3. How can you calculate such kind of questions? Textbook question. 1 mole of aluminum ion to aluminum, 1 mole of cupric ion to copper, 1 mole of permanganate ion to manganese 2, dichromate ion to chromium 3. Simply, how much charge is required to reduce? Reduction takes place. How many electrons are required to reduce? In case of the aluminum ion, 3 electrons. So, that is what? Q is equal to N into F. Number of electrons and Faraday is constant. So, in the question number 1, that answer is, see, 1 mole of aluminum 3 positive, you provided 3 electron, aluminum solid. So what is your answer? Answer is Q is equal to N into F. 3 into 96500 coulomb is the right answer. In case of copper ion to copper, second question. So that is the question number 2. In case of the copper ion, say copper 2 provided 2 electron, copper solid. So Q is equal to N into F. 2 into Faraday. You know the value of Faraday. So far as, dear students, permanganate ion, say here 1 mole of MnO4 1 negative, Mn2 positive. Oxygen 4 times. So balance this ionic reaction. Hydrogen 8H positive plus 5 electrons. Because of 5 or minus 1 6, 8 minus 2, and here this is the 2. 5 electrons are required to reduce. So first answer is N into F. 5 Faraday is the right answer. In case of last question, Cr2O7 2 negative, Cr3. Tell me how many chromium? 2 times. Oxygen 7. So 7 times water. How many hydrogen? 7 into 2, 8. That's why you write here 8 as positive. Let you balance the charge. Here 3 into 2, 6 positive. Required to reduce. Reduce always taking place in left hand side. So 8 plus and 2 minus. So what is that? 6 as positive. Q is equal to N into F. 6 Faraday is the right answer. So dear students, Faraday's first law of electrolysis, you can solve such kind of the numeric. Now Faraday's second law of electrolysis. It is defined as, it is stated as, when the same amount of charge is supplied through the different electrolytic solution connected in series, then the ratio between mass and equivalent mass of different electrolytic solution will remain same. Go through the definition. At a glance, what I have written: when the same amount of charge is supplied by the different electrolytic solutions connected in series, 1, 2 and 3 connected in series, then the ratio between mass and the equivalent mass of the different electrolytic solutions will remain same. Let us consider 3 different electrolytic solutions connected in series. Illustration by taking diagram. See, we take 3 electrolytic cell. Here 2 electrode provided here. In one tank we take aqueous solution of zinc sulfate. In this aqueous solution of what? Copper sulfate. And here aqueous solution of silver nitrate. This is what connected to each other by opposite pole right now, and this is the negative, and this side it is the positive. Here it is the negative, positive, negative, positive, negative, and what is that? Positive. The way we have taken 3 different electrolytes in the aqueous solution. One is the zinc sulfate, other is the copper sulfate, and third is the silver nitrate. What is the definition? That when the same amount of charge is supplied by the different electrolytic solutions connected in series, then the ratio between mass and the equivalent mass will remain same. See, according to this law, weight of silver is directly proportional to the equivalent weight of zinc. First is the zinc cell. Zinc is directly proportional to the equivalent weight of zinc. Weight of copper is directly proportional to the equivalent weight of copper. Again, the weight of zinc is directly proportional to the equivalent weight of what is that? Silver. Another form, weight of zinc deposited divided by weight of copper deposited equal to equivalent weight of zinc divided by equivalent weight of what? Copper. Another form, weight of copper deposited by weight of silver equal to equivalent weight of copper divided by equivalent weight of what is there now? Silver. Further, weight of zinc deposited divided by weight of silver, and that is the equivalent weight of zinc divided by equivalent weight of what is that? Silver. So weight is directly proportional to the equivalent weight. Weight of copper is directly proportional to the equivalent weight of copper. Weight of zinc is directly proportional to the equivalent weight of zinc. The way you can calculate, you can see Faraday's second law as well as the first law right now. So on the basis of that, we can solve some numerical based on the Faraday's law of electrolysis. You can see solve some numericals. Based on Faraday's law, a solution of copper sulfate is electrolyzed in 10 minutes with a current of with a current of 1.5 ampere. What is the mass of copper deposited at the cathode? What is the mass of copper deposited at where? Cathode. This is your question. And then see, I give you the two methods to solve this question. One is, you can say copper sulfate undergo electrolysis, Cu2 sulfate 2, you provided 2 electron, copper solid, 2 electron means what Faraday? 2 Faraday. Apply the unitary method. First, copper sulfate electrolyzed in 10 minutes with a current of, what is the mass of the copper? In the unitary method, whatever you have to calculate, let it project to the right hand side. It must be projected to the right side now. So, the mass of the copper deposited at the, say, what is the mass of the copper sulfate? Is electrolyzed in 10 minutes with a current of 1.5 ampere. What is the mass of the copper deposited at the cathode? So here, what was the Faraday we have taken? 2 Faraday of copper ion has the mass of copper 63.5 gram. Therefore, 1 Faraday of this 63.5 gram upon, what is that? 2 Faraday. Therefore, here what you have to take in coulomb? One thing that you have to calculate, that is the Q is equal to I into T. How much the current here? 1.5. How much the time? 10 minutes. 10 into 60. That means this point is out. 10 cancel. 900 coulomb. Therefore, you apply a 900 coulomb, 63.5, right, into 900 coulomb divided by is 2 into 96500 coulomb. Coulomb cancel. That is the 63.5 in the gram. So right now, then you solve this question and 900 coulomb and this 2020 also cancelled out. The way you can calculate the mass of the substance, and your answer will be, you have to take this is the 0.2938 gram, approximately 0.2983 gram approx is your answer. Okay, this is one of the methods we have solved this kind of question. Dear students, if you want to solve this question in another form, I give you very shortcut formula. Mass, whenever you have to calculate the mass or the weight, equal to I into T into Z. What is Z? Z is the equivalent mass, right? We have to calculate the mass. M or W, I is your current in 1.5 ampere. Time is 10 into 60. And what is the equivalent mass of? This is the equivalent mass of copper, 63.5 divided by 2. That's your answer. So you apply this formula. This is very important formula. I T into Z. Z is the equivalent mass of copper. If another metal will be there, then you apply silver like that, 108.1. यहाँ पे कॉपर इनटू पॉजिटिव 63.5/2. So one line numerical, you can solve it. See, solve the other question. If a current of 0.5 ampere flows through a metallic wire for 2 hours. Then how many electrons would flow through the wire? Calculate the flow of electron through the wire. So this is what it is, the very simple. Q is equal to N into E. There Q is equal to N into E. You have to calculate the number of electron. Q upon E. That is what it is, the what is that Q? 0.5 into how much? 2 hours. 2 into 60 divided by charge of electron 1.602 into 10 to the power minus 19 coulomb. That is your answer. Calculate the number of electrons. Metallic wire for 2 hours, 0.5 is given, and 2 hours, so change the minute and second, and in that it is what? See, solve the other question now. Other numerical based on the Faraday's law is that how much electricity in terms of Faraday is required, how much electricity in terms of Faraday is required to produce from 1 mole of calcium ion to calcium and 1 mole of how much electricity in terms of Faraday is required to produce 20 gram of 20 gram of calcium from CaCl2, and the another question is 40 gram of aluminium from AlCl3 or Al2O3, whatever it is. So dear students, how can you solve such kind of question here? Answer A, 20 gram of calcium from CaCl2. CaCl2 electrolyzed to form Ca2 positive plus chlorine 2 negative. You have to provide plus 2 electron, that is 2 Faraday. How much Faraday is required? The things you have to calculate to be projected right hand side. Then what is the mass of the atomic mass of the calcium? 40 gram of calcium ion requires how much Faraday? 2 Faraday. Therefore in 2 Faraday upon 40 gram. Therefore in how much here in question? 20 gram. Dear students, 2 Faraday into 20 upon 40 gram. Gram cancel. 2 से 2 cancel. What is your answer? 1 Faraday, that is approximately 96500 Coulomb. The way you can solve this kind of question. And the last question is 40 gram of aluminum from AlCl3 or Al2O3, whatever it is. AlCl3 splits to form Al3 positive, 3 chlorine negative. 3 electrons are required to reduce aluminum ion. So that the things you have to calculate to be projected to the right hand side. 27 gram of aluminum ion requires 3 Faraday. Dear students, therefore in 1, 3 Farad upon 26 gram. Therefore in numerical, how much gram is given to us? 40 gram. 3 Faraday into 40 gram divided by 26 gram. Gram cancel. So 3 say 9 cancel. So that is your answer is 4.44. Faraday is the right answer. This is all about Faraday's law of electrolysis is over after and electrolysis. In my next class, we will discuss Corlast's law of independent migration of ions. Thank you very much. Have a nice day. Thank you.